WCX-81. It is longer than a Boeing 747, and it carries so much weight that on some days it becomes the whole reason a train exists. Built in 2012 by Casgro Rail in Newcastle, Pennsylvania for Westinghouse, it is the largest rail car ever constructed in North America. It is a Schnabel car, which means the cargo itself becomes part of the car. The load, usually a power plant transformer or a nuclear reactor vessel, gets clamped between two massive end sections and suspended in the air. Empty, it stretches about 231 ft and weighs nearly 400 tons, roughly 800,000 lb of steel before it carries anything. Fully loaded, it hauls over 1,000 tons, more than 2 million lb spread across 36 axles with 38 in wheels. Hydraulics let it shift a loaded reactor up to 40 in sideways and 44 in up or down so the cargo can duck under wires while moving. But here's the catch. There are fewer than 100 Schnabel cars on Earth. And this one moves so rarely under such strict conditions that most rail fans will never see it. The biggest rail car ever built spends almost all its life parked. The Union Pacific Rotary Snowplow. Picture a giant steel fan bolted to the front of a rail car, spinning fast enough to fling snow clean off the track. Built in 1966 at Union Pacific's Omaha shop, it is the heaviest rotary snowplow ever made, stretching 52 feet and weighing 367,400 lb, about 184 tons. Its job is simple but brutal. When snow piles too deep for an ordinary plow to shove aside, this machine's rotating cutting wheel chews into the drift and throws it to either side of the rails. A 16-cylinder 3,000 horsepower diesel engine drives an electric generator that spins the blades. But here's what sets it apart. It doesn't move on its own. It has no drive wheels of its own at all. Instead, this enormous machine has to be pushed from behind by 3 or 4 locomotives, shoving it slowly into the snow. So, one of the largest, heaviest pieces of rail equipment ever built is technically just a giant attachment. Today, it survives as a preserved exhibit at the National Museum of Transportation in St. Louis. Its weight, by one museum's measure, equals 62 African elephants. The Torpedo Ladle Car. It looks exactly like its name. A giant steel cylinder lying on its side riding low across a web of rail bogies. Some crews call it the bottle car or the submarine ladle. Its one job is to carry molten iron straight from a blast furnace to the steel-making furnaces without letting it cool. Inside that shell is a lining of refractory brick. And inside that sits between 150 and 350 metric tons of liquid iron glowing at around 1,400 to 1,500 degrees C. Hotter than lava. Fully loaded, one of these cars weighs several hundred tons, making it one of the heaviest rail vehicles in everyday industrial use. The whole vessel can rotate in its cradle to pour. But here is what sets it apart from every other giant on this list. You will almost never see one. It doesn't run on public tracks. It spends its entire life crawling around the internal rail network of a single steel plant. Treated less like a train and more like moving process equipment. It is a rolling thermos the size of a house, and the world it feeds mostly forgets it exists. Union Pacific's TRT-9. In 2011, this machine rolled north from Elkhart, Illinois, quietly eating an entire railroad and laying a new one behind it. It is a track renewal train built to rebuild the very tracks it rides on, part of the Chicago-St. Louis high-speed rail upgrade. And it is enormous, nearly half a mile long, about 2,600 ft with locomotives, support cars, and roughly 30 material cars, each hauling 210 concrete ties. It doesn't carry freight. It works as a rolling factory. 3 sets of gantry cranes slide fresh concrete ties forward. The machine drops them into place, threads new rail on top, and pulls the old wooden ties and old rail out the back for recycling, all in a single pass. In one 12-hour shift, it can install up to 5,000 ties. Over the campaign, it laid more than 190 kilometers of new rail and nearly 250,000 concrete ties, backed by over 800 workers. But here's the twist. This colossal train never carried a single passenger or ton of cargo. When the job finished, it simply vanished from the line, leaving behind nothing but faster, smoother track for other trains to use. Ballast Tamper No. 1. This one is small, but its job is one no giant hauler can do. Built in 2003 by Harco Track Technologies in Michigan, it serves the Isle of Man Steam Railway and lives at Douglas Station when it isn't working. A ballast tamper is a maintenance machine that lifts a line and squeezes the crushed stone, the ballast, packed under the wooden sleepers that hold the rails in place. Over time, trains pound that stone loose, the track sags, and the ride gets rough. This machine drives its tamping tools down into the gaps and vibrates the stone tight again, lifting the track back to true. But here's what sets it apart from everything else on this list. It doesn't haul, carry, or lift heavy loads at all. It can even rotate on its own axis using a single onboard hydraulic leg, so it can turn itself around in tight spots. It is a named piece of rolling stock whose entire purpose is to fuss over the ground beneath other trains. When it's done, it is tucked away on Road Zero at Douglas Station, waiting for the next winter's work. The TGV Iris 320. From the outside, it looks like an ordinary French high-speed train, 2 power cars, and 8 articulated coaches roughly 660 ft long. Introduced in the mid-200s by SNCF Reizo and built from a standard TGV Reizo set, it is one of the largest and fastest track inspection trains in the world. Its job is to measure the track, its alignment, curvature, gauge, and rail profile using lasers, accelerometers, and inertial systems. But most inspection vehicles are single cars crawling along at low speed. This one does the job at up to 320 km, about 199 mph, sustained TGV line speed. That matters because some defects only appear when a train is truly flying. So, it slots into normal high-speed traffic between commercial TGVs and surveys hundreds of kilometers in one run without blocking the line, while engineers analyze the data in real time inside onboard labs. But here's the twist. This full-size, high-speed train capable of carrying hundreds of passengers was pulled from service to carry mostly computers and a handful of technicians. It looks like the train you'd love to ride and no ordinary traveler ever can. It rides ahead of the public, unseen, keeping the rails safe. The BHP Pilbara Ore Train on the 21st of June 2001, in the remote desert of Western Australia, BHP assembled the longest and heaviest train ever recorded. The numbers still sound impossible. The consist ran 682 ore wagons pulled by 8 General Electric AC6000 CW locomotives each, about 6,000 horsepower spread along the train end to end. It measured 7.352 kilometers, about 4.57 meters longer than many entire city rail networks. Its total weight came to 99,734 metric tons, carrying 82,000 tons of iron ore in one single move from the Yandi mine 171 km to Port Hedland. Controlled by a single driver using distributed power, where locomotives placed along the train are commanded electronically from the lead cab to keep the couplers from tearing apart on curves. But here's the catch. This was never a working service. It was a one-off test built purely to prove how far the system could go. Once BHP proved it, they never ran trains this size again, because such giants are inflexible and a nightmare to schedule. The biggest train in history was a spectacular demonstration of a capability nobody actually needed. The industrial brown hoist 150-ton wrecking crane. In the early 20th century, when a locomotive left the rails in a mangled heap, this is what railroads sent to pick it back up. Built by the Industrial Brown Hoist Company of Bay City, Michigan, the 150-ton version was described in 1914 as the most powerful breakdown crane in service. It was a self-contained railcar, a heavy multi-axle underframe carrying a steam boiler, and a long swinging jib riding at the front of a wreck train full of tools, coal, and flat cars for the wreckage. Its rated lift was 150 tons, about 300,000 lb. But here's the twist. That headline number was a lie in practice. It couldn't lift the heaviest locomotives alone. Technical writers of the day admitted that a serious derailment needed at least 2 of these cranes working together. And even then, the practical limit was only around 130 tons of engine. So, the most powerful breakdown crane ever built was at the same time too big to move easily, yet not quite big enough to do the biggest job by itself. Its own strength was a paradox riveted into steel. The catenary maintenance train. This one is the odd exception on the list. What is real and record-breaking is the machine that maintains the wires above electric railways. The catenary, the overhead lines that feed power to trains through a panogram raft on the roof. And the largest railcar it points us back to is one we've already met. Ask which single railcar tops every list. And the answer keeps returning to the Schnabel Wex 801 at about 231 ft empty and hauling over 2 million pounds of cargo across 36 axles. But here is the reveal. That car isn't even owned by the railroad. The railroad just supplies the locomotives and the track. The Schnabel belongs to a private industrial firm wandering the network like a guest. So, the biggest railcars in the world aren't railroad rolling stock at all. They are private tools borrowing the rails, moving so slowly and so rarely that the network barely notices they were ever there.